Now we are studying about the electric field at a point on the axial line of a dipole. In our previous classes we have already studied about dipole. What is electric dipole? An electric dipole has two charges, two different charges. This is positive, this is negative charge Q, and this is positive charge Q. These different charges are separated by a small distance. This distance is 2a. This is a dipole. Dipole is two different charges, positive charge Q and negative charge Q are separated by a small distance 2a. And then we consider the center point of this dipole is taken as O. The distance from O to this positive Q is A, and O to this negative charge Q is also A. Then we consider the axial line of this dipole. The axial line of this dipole passes through like this. This is the axial line of the dipole. The next step we are going to consider a point on this axial line, the point P. We are considering a point P. This is the point P on the axial line. And we placed a very minute positive charge at P. This point P is distance R from the center O. So distance is taken as R. At the point P, an attractive force is generated due to negative charge Q and a repulsive force is generated due to positive charge Q. Then two electric fields are formed there. First one is the electric field intensity due to positive charge Q is in this direction because there is an repulsive force is generated. So electric field intensity is in this direction. The electric field intensity at a point P is in this direction, and that is taken as E positive. And due to this negative charge, an attractive force is generated at point P. So the electric field intensity at point P is in this direction and is taken as E negative. So we consider two electric field intensities there. First one is due to positive charge Q is E positive, and electric field intensity E negative is the electric field intensity due to negative charge Q. Then the electric field intensity E positive is the electric field intensity due to positive charge Q is equal to, we already know the equation of electric field intensity is 1 by 4 pi epsilon 0 Q divided by distance square R square. Here the distance from P to positive charge Q is R minus A the whole square. This is R minus A. Here the distance is R minus A the whole square because distance from the center O to P is R and O to Q is A. Then the distance from positive charge Q to P is R minus A. Like that, the electric field intensity E negative. This is the electric field intensity due to negative charge Q is 1 by 4 pi epsilon 0 Q by distance square. Is the distance from negative charge Q to P is R plus A the whole square. Because the distance from P to O is R and O to Q is A, then R plus A is the distance from P to negative charge Q. Then the total electric field act on P is This a total electric field act on P is the total electric field act on P is the difference between E positive, the electric field intensity due to positive charge, E positive minus E negative. Why we are taken like this? Because electric field intensity due to positive charge is higher than electric field intensity due to negative charge. So we taken the difference. Because positive charge is placed more near to the point P. So electric field intensity due to positive charge is higher than the electric field intensity due to negative charge. So we taken the difference. The E positive is. We can take the common terms. Q by 4 pi epsilon 0 is a common term. Take outside. Then 1 by r minus a the whole square minus 1 divided by r plus a the whole square. Then the next step we are going to multiply this. Then we get E is equal to Q divided by 4 pi epsilon 0. When we cross multiply this, we get r plus a the whole square minus r minus a the whole square divided by r plus a the whole square into r minus a the whole square. The next step we are going to expand this. Then we get E is equal to Q by 4 pi epsilon 0. We can expand like in the form of a plus b the whole square and a minus b the whole square. So we get r square plus 2ra plus a square minus r square plus 2ar minus into minus plus 2ar minus a square divided by then r plus a the whole square into r minus a the whole square. This is in the form of a plus b into a minus b, r plus a in the whole r plus a into r minus a. This is in the form of a plus b into a minus b. Then we can write as a square minus b square. So r plus a into r minus a we can write as r square minus a square and give this square also. Then we cancel out these terms. Then positive r square and negative r square cancel out. Then plus a square and minus a square cancel out. Then we get E is equal to Q by 4 pi epsilon 0 2ar plus 2ar. We get 4ar divided by r square minus a square the whole square. In next step we are going to write 4ar into two separate terms. Then we get Q by 4 pi epsilon 0 2r into 2a. We can write like this. Then r square minus a square the whole square. What is 2a into q? 2a into q is dipole moment. We already studied that. 2a into q, q into 2a, charge into distance is dipole moment. Is p, dipole moment. Then we can write as E is equal to P into 2r divided by 4 pi epsilon 0 r square minus a square the whole square. The next step, we are going to assume that the distance a is very less than r. The distance a is very less than r because in a dipole two charges are placed very close together. So 2a is very less as compared with the distance r. A is very less than r. So we get we can cancel out this term a square. So we get E is equal to P into 2r divided by 4 pi epsilon 0 r. We cancel out the term a square, then we get r raised to 4. The next step, we cancel this r and one of this r. So we get the equation of electric field intensity at a point P due to dipole is E is equal to 1 by 4 pi epsilon 0 2 into P divided by r cube. This is the equation we got. This is the equation of electric field intensity at a